Hello everyone, am I audible?
Good evening. Yes, sir, I am audible.
All right. Hello Zaid, everything good? Zaid, am I audible? All right, I don't think so. Ishan, Ronaldo, Said, everything good?
Yes, sir.
All right, any doubts from the last class?
Yes, sir.
No, all right. Ishan, your voice is very low. So check
No,
if you
sir.
can. All right. Let's move on then. Few more questions on this. Show that. Greatest integer function is not 1 1 or onto, nor onto in set R. Where is the CIF? That is greatest integer, that is less than, give me a moment, all right, less than or equals to x. All right, I hope everyone knows what greatest integer function is. Everyone knows what greatest integer function is, yes or no? Ishan, Ronaldo, Said. Ishan,
Yes,
do you know what this is? Ronaldo? See, greatest integer function is nothing but if I put 3.5 in greatest integer function, what will be the answer here, Ronaldo?
so 3.
3, absolutely right. So all integers, all right, it gives all integers that is less than, that means 3 is lesser than 3.5, so 3 will be the answer. The integers that are lesser than 3.5 or equals to that number, that means if I put 4 here, so it will give us 4 because 4 is equal to 4. So integers that is equal or less. So if I put 2.9, then what will be the answer here?
So 2.
2.
2, absolutely right. If I put minus 5.9, what will be the answer here?
-5.
Minus 5. Is it right? Is minus
4.
5?
Minus 4.
It will be
Minus 4.
minus 4. So minus 5 is lesser than minus 5.9 or minus 4 is lesser than minus 5.9. Is it true? In a number line?
Then it will be minus 6.
Minus 6, absolutely right. See, if this is minus 5.9, then the number lesser than this will be minus 6, right? Minus 5 will be on the right side, right side.
Yes, sir.
So in negative numbers, keep that in mind that it gives the number lesser than that. So, and on the left side, so minus 5.9 will be minus 6. All right, I hope this is clear. So you have to prove that this is not 1 1 nor 1 on 2. All right, I'll give you a few minutes. So if we have to prove that this is not 1 1, then one example is enough, and same for on 2. All right, I'll give you a few minutes, try to solve this. Zed, I can see that your mic is moving, but your voice is not audible. Please check your mic connection. All right, Zed, everything good? No issues, Zed. If you have any doubts, you can reply on chat. It's okay, no issues. All right, there might be that issue if you go to the mic option in the Zoom and see what the option of mic you are choosing. If you are using earphones, then choose that option in the audio. All right, everyone solve this? All right, Zed, don't worry, it's okay. Try to solve this question. Ishan, everything good now? Internet connection?
Sir, better.
Better. All right. All right, Zed. No worries. We just started the class. All right. Today we are going to finish this chapter. After that, we are starting inverse trigonometric functions. So how to prove this is not 1 1? Zed, we have not done all this. All right, Zed, we finished the first chapter, relation, and all right. Please ask the team and they will send you the lectures. All the lectures you will receive, don't worry. All right, and after that, if you have any doubts, you can ask me in the class. All right. So how to prove 1 1? We can see that for 2.5, For 2.5, greatest integer function gives us 2. For 2.3, this gives us 2. So we can see, so for x equals to 2.5 and 2.3, we get the same images. So function is not 1. And what about onto? Non-integral values does not have any pre-images. So this is not onto. What did I say here? They have said R to R, right? R to R. All the real numbers are here, but greatest integer function only gives us integer values, right? 1, 2, 3, 4. So what happened to 1.1, 2.2, 2.3, and so on? They are not related to any numbers, right? So this is not onto. Is this question clear? Said, Ronaldo, Ishan?
Yes, sir.
Always please note it down. All right, note it down. Done, everyone?
Yes, sir.
All right. Next question. Show that the function f from R to R given by f of x equals to cos x for all x belongs to R is neither 1 nor onto. All right, try to solve this one. I'll give you a few minutes. You all know what cos x is, right? Trigonometric function cos x. Have we solved this? Let's see. Can anyone tell me what is the value of cos 0 degree? Does
One.
anyone remember this? 1 cos 0 is 1. Is it right? Cos 0 is 1.
Yes, sir.
All right. So cos 0 is 1. Can anyone tell me what is cos 2 pi? What is cos 2 pi?
So 1.
1. Is it right, everyone? Right. Right. Absolute right. Cos 2 pi is also 1. So we can see. So for x equals to 0 and x equals to 2 pi, we have the same images. So cos x is not 1 1. This is clear, everyone?
Yes, sir.
All right. Now about onto. What is the maximum value of cos x? Does anyone know?
180.
180. All right. Any other answer? Ronaldo, Said, Zaid.
So 1.
1. All right. Any other answer?
Sir,
Maximum value
cosine is its value from 0 to 1.
0 to 1. All right. So right. The maximum value of cos x is right. You can see in the graph also. If you remember the graph of cos x is this. Right. So maximum value it attains 1, and the minimum value it attains. What is the
-1.
minimum value? -1. Absolute right. So cos x and sin x always come between 1 to -1, -1 to 1, right? No other value can we get from that. So we can say that r minus -1 to 1, right? If you remove -1 to 1 from the real number, have no pre-images. So it is not on. All right. This is clear. If you take any number from 1 to infinite or minus infinite to -1, right? If I say 2, when will we get 2 from cos x? Never. So no value of x justifies the value 2. So 2 has no pre-image. So this is not onto. This is clear, everyone?
Yes, sir.
All right, please note it down. All right, done everyone?
Yes, sir.
Today everyone is in silent phase, I guess. Not in the mood to speak. No issues. Is it the case, Ronaldo?
No, sir. Actually, I'm sick, so I just don't want to like talk much.
All right. Take care. The season is changing. All right, next question. Let A equals to R minus 2 and B equals to R minus 1. If f from A to B is a mapping defined as f of x equals to x minus 1 upon x minus 2. Show that f is bijective. Right? You all remember what is bijective function? Do you all remember what is bijective function? Ishan, what is bijective function?
Sir, I think it is both one and one and one.
Right, 1 1 and on 2. Right.
On two. Sir.
So you remember how to check 1 1 function?
Yes, sir.
All right, and on 2 we all know, right? So please solve this. I'll give you a few minutes, and if you cannot, then tell me. I'll solve after a few minutes, but please try. All right.
Sir, can you solve it? Solve this?
All right. So how to check 1 function? Let x1 belongs to or x1 x2 belongs to A. All right, such that f of x1 is equals to f of x2. Ishan, remember this method?
Yes, sir.
All right, everyone, I hope you remember this method. How to check 1 f of x1 equals to f of x2. This implies just put the x1 value here. X1 minus 1 upon x1 minus 2 is equals to x2 minus 1 upon x2 minus 2. Now how we can solve this? Cross multiplying. So we get x1 minus 1 times x2 minus 2 is equals to x2 minus 1 times x1 minus 2. All right. So this is x1 x2 minus 2x1 minus x2 plus 2 is equals to x2 x1 minus 2x2 minus x1 plus 2. So plus 2 and plus 2 is cancelled. X2 x1 is cancelled. Let's bring x1 together. So this is minus 2x1 plus x1. Let's bring this x2 to this side. So minus 2x2 plus x2. All right. So this is equals to minus x1 is equals to minus x2. This implies that x1 is equals to x2. So the function is 1, 1. Is this steps clear, everyone?
Yes, sir.
All right, Ronaldo, this is clear.
Yes, sir.
All right, Said and Ahmed.
Yes, sir.
All right, please note it down. Then I'll explain how to solve one onto function. Done, everyone?
Yes, sir.
All right. So how to check onto function? I hope you remember that method. Let y belongs to b such that f of x equals to y. This is the first step. All right, y belongs to b such that f of x equals to y. This implies that what is f of x? F of x is x minus 1 upon x minus 2 is equals to y. Now our go to write x in terms of y. So how we can do that? Cross multiplying again. So x minus 1 is equals to yx minus 2y. Right? Let's bring all the x together. So this is x minus yx is equals to 1 minus 2y, right? This one is here, so 1 minus 2y. Let's take x common, so 1 minus y is equals to 1 minus 2y. So this implies that x is equals to 1 minus 2y upon 1 minus y. These steps are clear, everyone? What I did here? Everyone, this is clear? All the steps?
Yes, sir.
All right. So now, no matter what value you put in this instead of y, right? Y is all real numbers except 2 or 1, I guess. In the question, we had 2. So we cannot put y equals to 1 here, right? Because 1 minus 1 is 0. Except that no matter what value you put, we will never get infinite or imaginary numbers, right? This thing is clear. No matter what
Yes,
the
sir.
value of y, we will always get a real number out of here. So we can say, so for all y belongs to B, we have a x equals to 1 minus 2y upon 1 minus y, such that f of x equals to y. So f is an onto function. All right, I hope this question is clear, everyone. Please note it down. Tell me when you are done. Right, Zed. Yes, there is some notification about that class. You guys take one weekly class also, right? Of competitive exams, everyone. Ishan, Ronaldo, Said, Ahmed.
So can you repeat the question?
Yeah, there is one weekly competitive exam class scheduled for you guys, right? Every week.
I don't know
No, I
about
don't
that.
have such a class.
Don't have such a class. You don't take any other class of ethics except me?
So I do physics and chemistry.
No. Only mathematics I'm talking for competitive exams.
Oh, yes, sir. Only
Only
So for
me.
maths
All
only.
no. For each subject, I think our team schedules one more class for you on weekly basis. You don't take that class, everyone?
Sir, I did not receive any link
No,
to that
sir.
class.
All right, just give me a moment then. All right, just give me a moment. Till then, you guys solve this question. All right. Let me write the question down. Show that f from n to n defined by f of n equals to n plus 1 by 2 if n is odd and n by 2 if n is even is many one onto function. All right, try to solve this question and give me 2 minutes. Let me talk to the team. So none of you take any JEE or NEET class? Everyone? Anyone takes JEE or NEET class at Learnivio?
No, sir, not me.
Not yet, sir.
But
No, sir.
I believe we have been scheduling that for 2 weeks now. So I don't know how you guys missed it. All right, don't worry, I'll talk to the team. All right. And suppose from the next week you will start the class. Is it okay if we keep that at 8:30 at KSA time, that your time 8:30?
Sir,
You
which
can
date?
reply me on which date after my class.
Sir, I have chemistry tuition after your class.
You can just say yes or no. All right, just give me a moment. Let me confirm the days. All right, let me just confirm the days. Then you can reply me on chat. All right, I need that for that. All right, give me a moment. All right. Is it okay if we schedule that class on Monday or Wednesday at 8:30 your time? If that is okay, then reply me on chat. If that is not, then just say no on chat. All right. At 8:30. Ahmed, at 8:30. And you're at 8:30, not Indian time. Syed, I didn't receive your reply. All right, Ahmed, what about you? All right. All right, you have solved this question, everyone? Let's see how to check 1-1. If I try to find f of 1, what will be f of 1 here, Ronaldo? Ishan, Ronaldo, what will be f of 1 here?
X by 2.
1 by 2. How is it 1 by 2?
Sir, x plus 1 by
No,
2.
it's odd, so it will be x plus 1 by 2.
Absolutely.
No, 1.
1. Right, Ishan? If 1 is odd, that means we have to choose this one. So 1 plus 1 by 2. So this is 1. And what will be f of 2? Anyone has the answer? What will be f of 2 here?
Sir, x by 2. That is
X by 2. Right. So 2 by 2, that is 1. So for 1 and 2, we have the same image. So this is not 1 1. Right? This is clear. Now for onto. See, for onto, the function is says from n to n, right? So y can be any natural number. So natural numbers provide even numbers and odd numbers, right? So let n be any odd number. So for any n, there is an odd number 2n minus 1 such that f of 2n minus 1. What will be f of 2n minus 1? See, n is odd, that means 2n is even, 2n minus 1 is odd. So if we have to calculate f of n minus 1, then we'll take this one, this function. So 2n minus 1 plus 1 by 2. So this is n, right? So there is always a number 2n minus 1 such that f of 2n minus 1 we get n, right? Same thing we can say for even number. Let n be any even number, then for all n there is a even number 2n such that f of 2n is equals to 2n by 2 is equals to n, right? If you take any number, we will have a 2n number such that if you put that number in this function, we'll receive n. So function is onto. Is this thing clear or not? If you say, sir, how we can get 5? So I can say put 9 here, 9 plus 1 by 2, and we can get 5. If you say, sir, how will I get 12? So I'll say just put 24. If you put 24, 24 by 2 is 12. So no matter what the value of y, we'll always have a even or odd number in the respective way such that f of x is always that number. Is it clear or not, everyone? Ishan, Ronaldo, Said, Ahmed.
Yes, sir.
Yes, sir.
Yes.
All right, please note it down. Done, everyone? Done, everyone?
Yes.
All
Yes.
right. All right, next question or last question of this topic. Let A and B be two sets. Show that F A cross B to B cross A defined by F of A comma B equals to B comma A is a bijection. All right, try to solve this one, everyone. All right, everyone solve this. Who didn't even understand the question? Do we have any such warrior between us? Ronaldo, Ishan, Said, Ahmed? Nobody is going to reply. Ishan, Are you able to
Yes,
solve
sir.
this?
No, sir.
No. All right. See, this is one of the most, we cannot say difficult, but they want to trick you by giving this type of questions. Absolutely right, Ahmed. Right? Even I don't understand the question. So how we can solve this? Let's see. They are saying there is a function. Till now we are seeing function f from A to B. Right? This was a domain. This is codomain. But in here they are saying domain is A cross B and codomain is B cross A. Right? No matter what they set A and B, domain means you will take an ordered pair as the domain, right? So the input will be two elements A comma B, and the resultant would be also a ordered pair B comma A. This thing is clear? Ahmed, Ishan, this is clear till now?
Yes, sir.
All right. Now we have to check how this is a bijective function. So for onto, oh sorry, 1 1. First is 1 1. Same method. How we checked 1 1? We took x1, x2 belongs to domain, right? So here we have to take ordered pairs. That means let a1 b1 and a2 b2 belongs to a cross b, right? Because a cross b is the domain, such that f of a1 b1 is equals to f of a2 b2, right? F of x1 is equals to f of x2. Same thing we did here. So this implies that in the function, if you put it, it reverses the order. So here we'll get b1 comma a1 is equals to b2 comma a2. Till now everything is clear or not? Anyone has any doubts? All right, no doubts. When are two ordered pairs equal, we can say the corresponding elements are equal, right? So we can say b1 equals to b2 and a1 equals to a2. Any doubts on this?
No.
No. So this proves f is a 1 1 function, right? If x1 equals to x2, then f is 1 1 function. Same here, b1 is equals to b2 and a1 equals to a2. That means they are no two separate ordered pairs but same ordered pairs. So f is 1 1 function. Clear, everyone?
Yes, sir.
All right.
So
So please note it down, then I'll explain how to write onto. Done, everyone?
yes, sir.
Yes, sir.
All right. So how to check onto? Let b comma a belongs to b cross a. All right. We choose an element from the codomain, right? B cross a was the codomain. One element is all right, such that B belongs to B and A belongs to A, right? If B comma A is an ordered pair from B cross A, that means the first element is from the first set, second element is from the second set. This is clear. So can we say this implies that A comma B will also belong to A cross B, right? If B comma A belongs to B cross A, then A comma B must belongs to A cross B, right? Because the elements of A and B are same. Is this thing clear or not?
Yes, sir.
All right, such that A belongs to A and B belongs to. So what did this prove? This proved that for all B cross A belongs to B comma A belongs to B cross A, we have an element A comma B belongs to A cross B such that f of A comma B equals to B comma A, right? So function is onto. Is this thing clear or not? We chose an element from the codomain and we show that there must be a domain with that element as the result also, right? You put 4 comma 3, I'll have an element 3 comma 4 such that if you put that in function, I'll receive B comma A, right? So the function is onto. Hence the function is bijection because that is 1 1 and onto. Is this thing clear, everyone?
Yes, sir.
All right, please note it down. All right, done everyone, right? No doubt still now? Everyone, equivalence relation, 1 1 function, onto function, bijection, injection, surjective, everything is clear? Yes or no? Ishan, Ronaldo? All
Yes,
right.
sir.
Yes, sir.
So you can complete the NCRT. The one small thing is remaining, inverse of a function. Please write it down, inverse of a function corresponding to This is definition. Please note it down. Corresponding to every bijection f from A to B, there exists a bijection G from B to A defined by G of y equals to x if and f of x equals to y. The function G B to A is called the inverse of the function f from A to B and is denoted by f inverse. Note it down, everyone.
Sir, could you please read it once?
All right, I'll read it once. Corresponding to this video. All right. Corresponding to every bijection f from A to B, there exists a bijection G from B to A defined by G of y is equals to x if and f of x equals to y. All right, the function G from B to A is called the inverse of the function f from A to B and is denoted by f inverse. All right, and again let me tell you, f inverse is not equals to 1 upon f. This is very wrong. All right, they put you in jail if you write this. All right, FBI runs behind you if you write this. F inverse is 1 upon f, so don't write this ever in your life. All right, this is clear, everyone?
Yes.
All right. Done writing? Then I'll explain. Ishan, done writing?
So 1 minute.
All right. And Alia, are you in this class?
Done, sir.
All right. So what does it say? The first line is corresponding to every bijection. All right. What is bijection? Who can tell me what bijection is?
1, 1 and on 2.
Absolutely right. So first thing is clear. If we have to find inverse of a function, then the function must be bijection. Why is that? Let's see. First tell me if this is a bijection or not.
Yes, sir, it is.
It is because this is 1 1. 1 is corresponding to one element, 2 is corresponding to one element, and all the elements of ABCD are connected. So this is bijection. Now they are saying for every corresponding bijection function, there exists another bijection such that g of y is equals to x. This is very lengthy definitions. Nothing is complicated here. They are saying if you have a function f of x such that if you put f of 1, you get a. If you put f of 2, you get b. All right. If you put f of 3, you get c. If you get f of 4, you get d. Right. This is the function. They are saying there will always be another function g, where if you put a, you get 1. If you put the b, you get 2. If you put c, you get 3, and if you put d, you get 4. That is why this is called inverse. Suppose this is Delhi, this is Manali. If there is a road from Delhi to Manali, only one highway, all right, only one highway is there from Delhi to Manali. That means the other way around, there must be the same road from Manali to Delhi also, right? If you travel from Delhi to Manali using this road, and this is the only road from Delhi to Manali, then which road will you take to come back? The same road, right, everyone?
Yes, sir.
Yes, sir.
This is the
Yes, sir.
same thing with inverse function. Same thing. If you take 1, if you put in a function 1, then that gives you a. Then there must be a function where if you put a, you will receive 1, because this is 1 function, right? 1 is not related to any other element. So if we reverse this, this is Hamza Shikhani. If we inverse this, give me a moment. Suppose we had this 2.234 A, B, C, D. One was giving us A, 2 was giving us B, C, and so on. If this is F and this is G, F is 1, is G 1 and onto function? Is G a
No, sir.
bijection or not? Right? So we can easily see that if we are putting 1 in function F and that is giving us A, then we somehow we can find a function G where if you put A, you will receive 1. Why is this possible? Because this is 1 and onto, right? Remember the definition of function. All these sons must have a father, right? And all these sons must have only one father. But if you do this for many one function, suppose 1, 2, 3, 4, A, B, C. 1 is connected to A, 2 is connected to A. All right. If we inverse this, A, B, C, 1, 2, 3, 4. A will be connected to 1 and 2, B, C, and this. So in here, this becomes the set of all sons. This becomes the set of all fathers. So A has 2 fathers. So that is wrong, right? In society. So this is not possible. This is not possible. That is why the function must be 1 and onto. Why onto? Suppose there is one element left. That means when it is inversed, this son has no father, and that is also wrong. That is why for a function and its inverse to exist, the function must be a bijection. Is it clear now?
Yes, sir.
Yes, sir.
So you can look at the definition. The same thing is explained. All right. I hope it is clear. And Shekhani,
Yes, sir.
why did you come today? It's like almost the class is almost over.
No, sir, I was there, but I joined with my sisters, so that Ali and Nabil, that was me.
Oh, that was you.
Yes, sir.
All right, all right. I didn't know. Otherwise, I would have asked you questions. Right?
Yes, sir.
All right, no worries. So this is clear, right? So let's start inverse trigonometric function. All right. So just now I told you for a inverse to exist, the function must be a bijection, right? And previously, if you can see, I gave you a question, prove that cos x is neither 1 nor onto, right? Do you remember that question? Cos x
Yes,
is
sir.
neither 1 nor onto. But we are studying about inverse trigo function, inverse trigonometric, and that means inverse of trigonometric functions. So am I contradicting myself? Yes or no? Everyone, yes or no? Nobody understood what I said? See, I told you, for a inverse to exist, the function must be a bijection, but sin x cos x is not a bijection. But as you can see, we have a function called sine inverse x, right? That is the inverse of sine x. So how is it possible? What we do is, this is the graph of sine x, right? So you can see, if you put sine 0, then you get 0, sine pi you get 0, sine 2 pi you get 0, and so on. So this is not 1 1, this is many 1. So what we do here is, we restrict the domain. How do we restrict the domain? We only see the graph as this, only this much. All right, we only have this much as the graph, and don't try to write this now, just understand this, then I'll give you notes to write. All right, we only see this much graph. So if I draw this much graph, you can see I only reach all y only once, right? For all x, I only receive one y. Yes or no, everyone?
Yes, sir.
So at this domain, this is minus pi by 2 to pi by 2. I can say this sin x is 1 1 and 1 2, right? All the elements from minus 1 to 1 are there, right? Yes or no, everyone?
I don't understand.
You don't understand. All right. See, for us to calculate the inverse of a function, that function must be a bijection, right, Ishan?
Yes, sir.
And what is a bijection? That function must be 1 1 and on 2, right?
Yes, sir.
So how do we calculate 1 1 function? For all x, if we see a graph, for all x, there must be only one y, right? No 2x should give us the same y, right?
Yes, sir.
Ishan, is this clear? So can you tell me, in this graph, do you have any y that gives us 2x or 2x such that we reach the same height, right? Y means height. Can you tell me 2x such that we reach the same height? If you put this value, then this height is reached. If you put this, if you move somewhere left or right, then the height changes, right, Shan?
Yes, sir.
So can I say that in this range, in this domain, this graph is 1 1? Yes or no?
Yes, sir.
Now how to check onto function? If I define this sin x from r to minus 1 to 1, if I make this codomain, then this will be onto also, right? The maximum value of sine is 1, minimum is minus 1. So all the values will reach here. The two codomain will be equals to range, right? Ishan, this is clear? Ishan, is this clear or not? Ronaldo, Shekhani, this is clear?
Yes, sir.
No response. All right. So that's why we limit the domain to minus pi by 2 to pi by 2. And this is not necessary. You can take anywhere. All right, this part or this part or this part, all the parts are same, right? If you restrict the domain, then sin x becomes 1 1 and on 2, and we calculate the inverse of the function. So please note down the graph. Give me a moment. All right, so we have to draw the graphs of trigonometric functions. All right, in this part we'll draw the graph of sin x, in this part we'll draw the graph of sine inverse x. So what is sin x graph? This one, this is pi by 2, this is minus pi by 2, this is 1, and this is minus 1. This is sin x. So what is the domain here? Domain here is minus pi by 2 to pi by 2, and range here is minus 1 to 1. Right, everyone, this is clear. This is graph of sin x. Now what is the graph of sine inverse x? See, sine inverse x is just the opposite of sin x. So the domain will become the range, and the range will become the domain, right? So if you put minus 1 here, if you put minus 1, sorry, this is 1, this is minus 1. If you put minus 1, then this graph will give us minus pi by 2. And if you put 1, then this graph will give us pi by 2. So at 1 we will reach pi by 2, at minus 1 we will reach minus pi by 2. So the graph becomes something like this. All right, this is the graph of sine inverse x. Here domain will be, the domain and range are interchanged when we find the inverse function. As you can see in this previous example, if you put 1, we got a, but in the inverse, if you put a, we got 1. So domain and range are interchanged. So in here the domain will be minus 1 to 1, and range will be minus pi by 2 to pi by 2. Is it clear or not, everyone? Everyone, is it clear or not?
Yes, sir.
Yes, sir.
All right, please note it down. And this domain, I'm talking about only principal. Just write the domain as R. All right, don't write this here, otherwise you will be confused. See, domain of sin x is R, right? We can put any value. But to calculate sine inverse x, we are constricting the domain, restricting the domain to minus pi by 2 to pi by 2. All right. So don't write this here. That was to explain you. Put domain equals to R here. Done, everyone? Ronaldo, Said, Shikani.
Yes, sir.
Yes, sir. Done.
All right. So how to draw this graph? Remember this. When put pi by 2, we get 1. So reverse this. When you get 1, you will get pi by 2. So this will be point in sine inverse x. The same thing with the other. If you put minus pi by 2, you receive -1. So if you put -1, you receive minus pi by 2. The curve will be like this. All right. Now let's see about cos x. All right. So the graph of cos x is this. Right. So we restrict the domain to 0 to pi. All right. So here domain is, this is cos x. Domain is R. Cos x is possible for all real numbers, but range is again -1 to 1. So what will happen to cos inverse x? What will be the graph here? See, graph we are going to plot for this only. So if you put pi, we are getting -1. So if you put -1, you will get pi. Everyone, this is clear. If you put pi, you get -1. So if you put -1, you will get pi. So this will be a point in the graph. If you put 0, you reach 1. So if you put 1, you will reach 0, right? So the graph will be something like this. I hope the graph is clear, everyone.
Yes, sir.
All right, so always try to draw this graph like this. So domain here, again domain is from -1 to 1, and range will be 0 to pi. All right, because we restricted the domain range from 0 to pi. All right, is it clear?
Yes, sir.
Everyone, this is clear or not?
Yes, sir.
All right, note it down. Done, everyone? Everyone done this graph?
Yes, sir.
A graph of tan x. Anyone remembers the graph of tan x? Right, this is 0, this is pi by 2, this is 3 pi by 2, 5 pi by 2, minus pi by 2, minus 3 pi by 2, minus 5 pi by 2. Alright, so this is from infinite to minus infinite. Same here, infinite to minus infinite, infinite to minus infinite. Alright, as you can see, my handwriting was really bad and drawing is the worst in the world. So please draw, you guys draw this in a good way. Alright, this is a pretty curve like this. Alright, so we restrict the domain here from minus pi by 2 to pi by 2. But domain of tan x is all
So
real
if
numbers.
I restrict the domain,
Sorry, Shekani, what did you say? Shekani, can you repeat? What do I mean by restrict the domain? Shekani, restricting the domain because if I take the domain real numbers, then this function is not 1 1 or onto, right? In fact, this is onto but not 1 1. So to make this 1 1 function, because I want to find the inverse, that is why I'm restricting the domain. That means to find tan inverse, I cannot put anything beyond minus pi by 2 to pi by 2. All right, Shikani?
yes, sir, understood.
All right. So domain of tan x is r minus 2n plus 1 by 2 pi by 2, right? Odd multiples of pi by 2n plus 1 pi by 2. Right, we cannot put pi by 2, 5 pi by 2, minus pi by 2, everything, because that becomes infinite or minus infinite. So that is wrong. And range is minus infinite to infinite, or we can say all real numbers. All right, this from class 11th you must know already. So what will be tan inverse x? How to draw the graph of this? Now I told you we restricted the domain to minus pi by 2 to pi by 2. So we will always look at this graph, only this part. So at this part, if I put pi by 2, I get infinite. So opposite of that will be if I put infinite. That means if I put x equals to maximum, then the function will reach to pi by 2. Right? If we put the maximum value, then the function will reach. Give me a moment. All right. Then the function will reach to pi by 2. And if I put minus pi by 2 here, then this becomes minus infinite. So if I put minus infinite, this will get to minus pi by 2. So infinite in 0, it is 0. So this is the graph. Again, draw a pretty graph. I have a really bad way. All right. So this is the graph of tan inverse x. How to All right, am I audible, everyone? My Wi-Fi got disconnected. Everyone, am I audible?
Yes, sir.
No, Shikani, class is not over. My Wi-Fi got disconnected, so I was disconnected. In 15 minutes, the class is over in 15 minutes. All right. So draw this graph. This is clear, right? Was I disconnected in between, or is it clear, everyone? All right, I think this is clear.
Sir, done.
All right. Now the graph of cortex. This graph is like this. This is 0, pi, 2 pi, minus pi, minus 2 pi, and so on. All right. So we restrict the graph to 0 to pi. All right. But domain of cortex is all real numbers except n pi, right? If you put multiples of pi, that will become infinite or minus infinite. So that is not the clear here. So n belongs to z. We cannot put n pi. Range is r, or we can say minus infinite to infinite. All right. So what happens in cot inverse x? To draw the graph, again look at this graph only. If you put 0, you get infinite. So here, if you go to infinite in x, you will reach 0. That means if you move to infinite this part, you will reach 0. And if you put pi here, you get minus infinite. So if you put minus infinite here, you get pi. So the maximum value that will reach is pi here. All right. So this is pi, this point and this point. So to join that, we have a graph like this one. All right. This is pi and everything. Right. So domain in this is R. You can put anything in cot inverse x, and range will be 0 to pi. All right, I hope this is clear, everyone. Ishan, Said, Ronaldo, Shikani.
Yes, sir.
Yes.
All right, draw it out. Done, everyone?
Yes, sir.
All right. Any doubts till now? Anyone has any doubts till now?
No, sir.
No, sir.
All right, so rest of the graphs we'll do in the next class. We don't have much time left. All right, and the relation and functions is clear, and most of the questions that you need to know I have done already in the class, as you can see. So please keep revising the questions. All right, most important, that was a difficult chapter. Rest of the chapters, 3 chapters we're going to do is very easy. Continuity, differentiability, application, very easy chapters. So please focus on the relation function chapters and keep revising all the previous chapters. All right, everyone, is it clear?
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
All right, then take care, guys. See you in the next class.
Thank you, sir.
Thank you, sir.
All right,
Thank you, sir.
all right.